Okay, we're on. Got about 15 problems here. This is the VF1 Heathkit. Anyways, I'm going to try to see if I can get something out of her. I'll put this on. How about there? I'll put it on the one down, I think, which would be what? Well, I can't spend all day on that. Okay. Anyways, we're at the 1862 bench. I don't know if that's porcelain or ceramic. The variable capacitor has that stuff on both ends too, so it looks like they use very high quality. There's another coil assembly down there. I didn't notice this solder before. So we're going to try to get it working here. My last video wasn't so successful. So I took the ohm meter here and checked this to make sure it's, okay, because it looked kind of iffy to me. Okay. And then I open this. Whoops. I think this opens up. That's on pin 7. Cathode. Heard that long enough. So I think that's one of those 200. What is it? 250 millihenries. RFCs. And this here, they got a 10 watt and a 2 watt. I don't think that's a Heathkit idea. And this here has a jumper across this capacitor, which I think that could be something like you leave this jumper on while you calibrate it and snip it for use or something like that, or vice versa. I don't know why, but that's been soldered in since day one, I think. So this is the 6AU6. 6AU6. I copied this from a 12BE6 from the S120 schematic. I didn't look it up. So, and this ain't here. I'm waiting for a tube, a 60E7, I believe it's called. I remember a 13DE7 when I was a kid on vertical oscillator output. I blew the cathode out on this baby wire. Where is it? Right here. Is this it? Right here. I think I blew it right. It flashed, and I couldn't. I thought the meter went out. There was a flash, and this one side of the tube. Here it is, right here. One side of the tube. You can see the wires right up to the glass. So I'm waiting for some of these to come. I might have some, but I'm not going to dig for them through my unknown tubes. I may have to put this in there. This thing really drags the B plus down in there. That's why I didn't put it in there. I use quantity of two 220K resistors like guitar amplifiers use instead. And that takes the voltage down. I didn't realize when this is, I think the idea is this, so when you let go of the microphone, it pulls the voltage down to nothing for safety reasons. So I'm waiting. I don't know. I don't know. But this thing worked the last time I monkeyed with it. And I don't know if there could be oscillation from the microphone. So when I turn it on again with a new tube, I will have the 12AX7 out. It's actually a 12AT7 in there. Somebody put in there. But anyways, and then on this thing here, so I got some of these should be here on Tuesday, I think. And today is January 18th. 2025. Get the date correct for once in my life. This ain't here. I was looking at stuff, monkeying with it on the other video. I don't think I could put the other video on because I said things that can't be said in today's world. Words. But this one here does have that 4.7K, not 47K. And I'll get to this after because this ain't what it's about. And this here, I discovered that I should have a 22K resistor here and a 0.01 slapped to ground. And that could be why it's not working. We'll get to that maybe later. So I'm just using the power supply off of it. And I got a 100K drop-in resistor here, so I was going to put that down to 47K or way down because I don't know. When I had this going, it only had 29 volts there. So I thought, okay, that's not good. So I might have to put this back in there to drag the B plus down if it has something to do with blowing out the cathode of the 6DE7. So right now, I knew the filaments are 3 and 4. I know that. They're all like that, and the 9-pin ones are 4 and 5, I believe. So the only thing that last night, common sense told me that this is negative, positive, and the white one was filaments. But now I changed my mind because I think this is filaments, and this is B plus. Obviously, they're using a shield for negative and shielding. It needs to be shielded. So again, I figure this off is off, standby is filaments, and on adds the B plus. So I'm just going to leave this with the B plus on. I don't need it on standby. So I figure the RFC choke is good. Somebody had a piece of paper in here when I got it, so keeping that open. I don't know why. Yeah. So this is a 6AU6, and this is the voltage regulator tube. And another thing, they don't have it hooked up so that if you pull the tube out, you can use this without the tube in it. It just doesn't voltage regulate. There is a connection from one of these to another one, so you can have that in your connection. So you pull the tube, the item won't run. But with this thing here, I don't think it matters if you got a tube in it, or that tube in it or not. It's just, I don't think it matters on something like this. But anyways, I got to get this hooked up to this. I think I'll shut this off to save time. So the RFC choke is good, apparently. And the plate is pin 5. I put this in green, I can't even see it. 5 is 7, 6, 5. So this one is on the plate. I don't see anything else. It's got to have a wire dot. Probably this wire. Yeah, that's a filament. Well, I'll hook it up and see if I can get the tubes to light. Yesterday I couldn't get the tubes to light because I was using negative, positive, and this other thing. But this other thing, this white wire, actually comes into this here. It's spliced together. I kind of forgot about that. It comes up here. So it must be some kind of a remote operation, so you can open the cathode up here to stop it from oscillating. I don't know if that would have something to do with Morse code, but Morse code I believe is taken care of right there. And I do have the proper plugs. I could plug that in if it was working. And the crystal, so I imagine you got to figure out which one's the low side, because yeah, this is going to probably break. Low side, high side of the crystal, I would assume. So I'm going to pause this and turn this thing on and get my oscilloscope out here. I think I need that. And hook the power supply up to it. So till then, my throat is all messed up. I think it's from what's going on, what I was talking about on the other video. But I can't talk about it because currently it is a sin. Okay, I've got it back on. I have the filaments hooked up to black, B plus hooked up to here, the red, minus hooked up to here, and over here I got the B plus on the far side of the 100K right now. I'm gonna disconnect this, even though that thing oscillates, but it's so weak. I had it oscillating last night again, and it's very weak. Negative, this swings around a purple wire and ends up over to the lug next past that green one is, the next two lugs are negative, and then one over here is negative. In between those two capacitors is negative also. Yeah, so positive is this way and positive that is that way. So I think I'm safe to go without burning out the filaments. The filament let me take that tube shield off here. So we'll have to look at this tube. I forgot to check the light bulb, so I think I'm ready. So I guess I'll plug it in, and again, just using that for a power supply. And that does get it, a couple hundred volts, 2 1/4 or something. And this thing here, I think on the back of it for the VFO produces 300, I believe. So we'll plug it in. And the cord here I'm plugging in is a polarizing plug. She's in. Oh, great. We got light. Now I got a circle on my screen. I don't know what that does. That usually makes it out of focus. So I touch the screen until she comes into focus. So we got B plus. We got filaments from there, so we should have B plus also. I'm going to hook this up from here. If I can see from here. I can't see it. My reading glasses don't have no depth of focus, so I have no... for focus for my face right up to it, and that's it. Okay, so we got that grounded. Here's our reference on the tube. We don't have to worry about the voltage regulator. I'd imagine that's not lit up because we only got a fraction of voltage here. Yesterday I was using it with it on ohms. Didn't work very well that way, so we're at 1,000. Yeah, actually I could take that down one because this is only going to be like 20 some volts maybe. So I'm just going to go in between these two resistors. Easy grab, so it's saying 12 volts, I think. So I'll go on to the far side, or the close side of the 100K. There, I seen a spark. We're energized. So now we should probably be at least over 100 volts. 160 volts, I think. So that should be enough to make this thing oscillate. It's supposed to be 300 volts, I believe. But but let's go here. 180, almost could be called 180. It slipped off, so we'll just call it 180, 185. So why they did this doesn't look. You don't normally put 2 watts with a 10 watt, unless if you're hunting something burned out and you're hunting for a a value, but this does not have electrolytic capacitors on here at all, so there's nothing to short out and burn out. What you see is what there is. Basically, there ain't nothing on this side, just the top side of the coil and the two tubes, I think, except for this stuff. But that's high frequency capacitors in there, and there might be an RFC choke in there or something. So I got this going. I have to pause, I guess, to turn on the oscilloscope and hook it up someplace. Shut the meter off because I got a low battery. I gotta watch that plug. That thing's got high voltage in it. The plug end. So let me just see what it gives here, if it works. I don't think there's anything that has to be replaced as long as the RFC choke is good. I don't have a schematic for it, so, and I think I looked on the internet on some stuff. But I don't really have the internet. I have to go to the library, so I'll go there later today because I want to look something up politics-wise. See if we're going to survive the storm, the big snowstorm of politics. So it dawned on me that I can hook up to here. Shield is the lower side there. See what happens. See if I get anything. I might not. I do. Oops, I was doing this wrong. What the hell? What the hell? What do I have it at? 5 volts. Whoops, wrong way. 5 volts is it. If I go here, if I change this, even though I'm straight circuit in here, I have no, I don't have a oscilloscope probe. I'm just straight in. Maybe I should get a oscilloscope. Well, I got 6.34 megahertz. It's frozen when I have this up. I'll go to the X10, just like if I had a probe on. But I think all it does is change the math. So now my math is wrong. Let's go back to straight probe, I guess, X1. I guess that's the 1000 ohm input at the oscilloscope end. 39 volts peak to peak. 17 volts RMS. That's a lot of voltage here. $17 volts. What the hell am I doing? What I'm doing something. I'm not doing something I should be doing. Like know how to operate it, I guess. Okay. We'll just put it on standby. Off. Standby. On. We'll turn the frequency thing. So it's a band spread deal, so it just does very little frequency change, I guess. Well, the green. It's got a green thing behind it. We should look at the. Okay, let's just go to the far left. This thing just keeps going. Oh, there's not a stop on it, on this variable. Okay, there's a line here, so we'll start from the line. Where's the frequency? Okay, I'm not touching it, so I'll just start turning it. I think it's going counterclockwise, so 643. I think it's going down. It's going counterclockwise, so the frequency is 6 something. I don't even know where I'm at here when I'm switched on here. I'm on 11 meters. Let's go to here. Let's do that. That's more fun. There. So this is showing, saying nothing. Oops. Okay, sometimes if you like have this spread out too far, it's going to show nothing here. I'm not showing peak-to-peak voltage. So if you get the frequency more on spot, then it'll work. So 1.86. That's a nice sine wave, I guess, if that's what it's supposed to be. I'll start from the far left, is why I couldn't put on the last video. That's too far on the left, and I didn't realize it. So now I'll start moving more towards center. Wait. So I'm on the far left. I'm going to move towards center, we'll just call it common sense. So I think I'm on, I don't know what meters I'm on. I'm on 3 of them at once, I guess. Pick your meters. 2 hertz, which would mean what? Here's 21. Maybe it's that scale. 2. No, that's a single number. I think we all got double. Well, maybe just eliminate the second one. I don't know how this thing works. How you figure it out. I would, if I was to use something like this, I would use a frequency counter. Just make sure you're on. It's because you can't turn this thing on unless you know where it's at. Or you go to, I can't say. Okay, I'm just going to turn this from far left towards common sense. So we got 2. Here we go. I can't take that voltage down anymore. I don't understand. Where the hell am I? I'm starting over. Oh, wait. What the hell am I doing? Wait a minute. There's more scales than There's more scales. I come to a line now. We come from this scale from double digits in front of the decimal point. Now we're to kilohertz. Look at there, kilohertz. Wow. So we got 4 digits of kilohertz. Now we got megacycles again. Double digits. So how do you do it single digits? I thought I had single digits going here. Okay. So we know there can be a future by what's beyond the horizon towards common sense. Okay, I didn't know this thing did common sense. Okay. Anyways, it works. I got to look at I'm not going to get that accurate because I expect explosions here. If I keep screwing with it, I don't want to wreck it. So the RFC choke, obviously good. I don't know what this bit is about. You want to use a foot switch like a guitar pedal. Why? I don't know. To open her up. Maybe it's a floor switch so you can open it up really quick so you don't get big oscillation. So you can hit your. It's like a kill switch on a anything. A drill, anything. Grinder. You don't want to get hurt, hit your kill switch. So I don't know what's going on here. I don't know why this loop, I don't know if that should be cut or why it's there. Why put the capacitor there? The builder should have kept the capacitor. It's a 0.005, I think, for another project, if that's the case. So I was hoping for it to have a 6AU8. It was one of my tubes we built CBs with when we were kids. I like to know how to build a CB radio with a 6AU8. Not a 6U8, the tall bottle, 6AU8. I bought some of those tubes. I'm going to be farting around with that. I'm going to be farting around with this thing again, too. This thing here, I don't know. You get up to, what did I measure? How many volts did I measure in that thing? I can turn it on now without the 6DE7 in it. I got over 600 volts. Right around 600 volts, I think. But on the paperwork I got, it doesn't. I don't even see a B plus for the finals or the B plus. So I may have to put that green resistor back in to pull the B plus down. Because I got a 220K on the bottom, stack of the capacitors, and a 220K to equalize the voltage like they do in guitar amps. And yeah, I guess this thing's working. I got to look at the filter, voltage regulator tube. So here we got 7 megahertz. I'm going to put it on the kilohertz scale. Kilohertz would probably be 11 meters. I think that's CB. 11 meters, I think, is a CB frequency. So I don't know what the... Looks like we got a wandering amplitude voltage problem here. It's wandering. Let's get on something, a stable number here on the kilohertz. Let's go to 37. I don't know which one I'm on. Well, double digits, 1873, who knows? 6.32, so that's what, 63? 63, did we have that? That scale. It had to be, but it's, I'm only at a, what, 100 and, let's look. Only at 100 and, some volts here. And we got this here too, so we don't know. Let's see how these feel. Cold. That might be just a slight lukewarm. Just fine. So we'll just go to the high B plus here, and we're at 177 volts. So this thing should be at 300 volts. I think the plug on the back of that says 300 volts. So it probably works just fine. Might have to adjust this. There's one on the top. Then you got all these. There's one here. I'll shut it off and flip it around. This seems to be working just fine. How do I shut it off? I know. Unplug it. See if I get a shock. I'm usually pretty good at unplugging stuff single-handed. So this is filaments. I'm going to write down here, move that out of the way and write filament or fill. Excuse me. And get my oscilloscope out of the way. This is negative or ground. So I probably should use a oscilloscope probe with this, and then I won't be overloading my oscilloscope. I don't know why it's that much voltage coming out of this thing. So you got 2 adjustments on the top. And when I figured out that black was filament, I stumbled onto it. Oh, I forgot to do that. Look at that. Shoot. Well, I'll put this on pause and hook it back up. Shoot. Okay, back on here. I can't have this on. That's going to light up right away. So I'll just leave it sit there. I got everything correct. B plus into this thing, it should be lit up. Maybe it's no good. See? I'll hook my oscilloscope up real quick, make sure it's still working. I'm almost out of time, so I got to work quick. This thing here needs, I can't remember if I mentioned it, needs like a 22K resistor there, and then a 0.01 to ground. I'm not getting nothing. The filaments are lit. I supposedly got B plus here. Oh, I'm on the wrong side of the resistor. Ah, I can't see it. Damn it. This negative is right by that too. Okay, here we are. So we got a frequency. I'm almost out of time here. Still ain't lit. Should be seeing glowing inside of it. But these kind of things, you can unplug these tubes and they don't do diddly. Let's see. I have some of these too, but I don't have one handy. I have no way to test them. My tube tester does nothing with zeros. But it's going to shut off. This is it. Signing off. At 6.36 megahertz. Signing off. This is it. Orange out.